So in the so far what we've done is we have analyzed or tried to find out regression equations using regression coefficients. Now we can also use the least squares method to obtain regression equations. Now note that both methods can be used to find regression equations, but if it's mentioned in the question to use least squares method, then you use the least squares method. And we try to fit a regression line. So if y is dependent on x, then the regression line will look as follows. And if you remember, a and b will determine the line. That is the y-intercept. A is the y-intercept in this case, or the value of y when x equal to 0, and b is the slope, which shows the which is also called the regression coefficient. So it's the same as byx, as we have which we have dealt with previously, and it shows how much y changes when x changes by 1. So using the least squares principle, because the values of a and b will determine the shape of the line, and the line should be drawn through the plotted points in such a way that the sum of deviations or the difference between the actual the sum of the squares of the deviations are nothing but difference between the actual y values and the expected y values. So the square of that should be minimum, and we will get that, or we will get those values of a and b, which give us this equation and which satisfy the least squares principle when we solve for the value of a and b using these normal equations. So the value of a and b when substituted in this equation will give us the line of best fit. That is the line which ensures that the sum of deviations, the square of the deviations, is minimum. And if x is the dependent variable, if x is dependent on y, so your regression equation of x on y will look like this, where a will be the regression, or a will be the intercept, the x-intercept, which means it shows the value of x when y is equal to 0, and b will be the slope, or in this case it is also interpreted as the regression coefficient bxy. And to find the values of a and b, we have the normal equations which look the same as the previous one, but in case here, in case of y, we have x and na plus b summation y exy equal to a summation y plus b summation y square. So they look almost the same, but there's just a slight difference in the way x and y are written. So using these equations, we get the values of a and b, and this will give us the line of best fit according to the least squares principle. So let us take an example of how we can find regression equations using the method of least squares. So here is an example where we have to calculate the regression equation of x on y from the following data. So regression equation of x on y tells us that x is the dependent variable, and since x is the dependent variable, our regression equation should look like this. Our regression equation should look like this, and to find the values of a and b, we will use these two normal equations. So the values we need to find are ex. You will already know what is n from the number of observations. You need ey, you need summation x, summation y, summation xy, then the summation of y square. Okay, so those are the values that we need to find out. So they will help us in solving for a and b. So let us put down the values of x. We have 1, 2, 3, 4, 5. The values of y, we have 2, 5, 3, 8, 7. So how many pairs we have? Let me write that properly. We have 2, 2, 5, 3, 8, 7. So how many pairs? 1, 2, 3, 4, 5. So your n value here is equal to 5. We need to find summation x. If we add that, we get 15. We also need to find summation y. Add these values, you get 25. Then what else do we need? If we have to find the regression coefficient, we need y square. Okay, so 2 2s are 4, 5 5s are 25, 2 3s are 9, 8 is a 64, 49. So we need summation of the y square. We get 151, and we also need summation xy, which means you multiply x and y. So 2 1s are 2, 2 5s are 10, 3 3s are 9, 4 8s are 32, 5 7s are 35. So the sum of this is equal to 88. So now the regression equation of x on y is x equal to a plus by. So in such a case, the two normal equations are as follows. Okay, so your normal equations here, they are nothing but simultaneous equations, which means if we solve both of them, what we're able to find is the value of either a or b. And suppose we solve first for the value of b, then we can use b to find the value of a. So we already know these values. Okay, so we already know these values, summation x and a from the calculations we did above. So simply substitute the values. So substituting the values, we get 15 equal to 5a plus 25b, call that as equation 1. Then summation xy is 88, 25a plus 151b, call that as equation 2. So these are, so now we're dealing with simultaneous equations. So for solving these simultaneous or normal equations, so for a, what are the coefficients of a? 5 and 25. Coefficient of b, 25 and 151. So the key here is to make the coefficients of either a or b the same. So once the coefficients are the same, we can remove either a or b and find out the value of the other variable. For example, if we want to remove a, what we can do is make the coefficients the same. If we look here, the one coefficient is 25 and one is 5. So how do we make them the same? If you multiply this by 5, right? So we'll get the same coefficient, and if we subtract, we can remove a and we are left with b. So that is how we find b. Or suppose you start with b, you make the coefficients the same, so that way you can cancel b and you're left with a. So that is the key of solving these normal equations or simultaneous equations. So let us solve for a. So we multiply equation 1 by 5. Okay, so if you multiply equation 1 by 5, we get how much? 5 into 15, 75, 5 into 5, 825a, and 5 into 25 is 125b. So now we subtract it from 2, because here we have 25a, equation 2 also has 25a, so we can cancel them by subtracting. So because you're subtracting from 2, so equation 2 should be written first, then you write equation 1, which has been multiplied by 5. So you subtract, and when you subtract, the signs changes. So these signs, because nothing is here, it means positive, so it becomes negative. Nothing is here, positive, it becomes negative, positive, negative. So positive, positive, negative cancel each other out. Because these are different signs, we have to subtract. So we get 13, and since 88 is a bigger number, we take the sign of the bigger number. And here, since 151 is greater than 1 minus 125, the difference is 26, and we get the sign of the bigger number. So straight away here we can see that b is nothing but 13 divided by 26, and if we check, we get 0.5. And since we've solved for b, we can simply put the value of b in either equation 1 or 2 to find the value of a. So you put the value of b in equation 1, we get equation 1, look how, okay, so equation 1 was 15 equal to 5a plus 25b. So 15 equal to 5a plus 25b. So you know what is the value of b. You can simply substitute the value 0.5, and what we get is 5a plus 12.5. so you bring 12 to the other side, get 5a. No, sorry, you have to always try to bring the lower number to the other side. Okay, no problem, it doesn't change anything. So let us bring, so if you bring 12 plus positive 12.5 to the other side, becomes negative, because 15 is the bigger number here. So here we get 2.5 equal to 5a, or equal to a. So if you divide 2.5 by 5, you get 0.50. So now you know the value of a, you know the value of b, which means now you know the value of the regression coefficient of x on y, and you know the intercept of y. And b is also the slope of the line, which you try to fit through the plotted points, or the line of best fit. So putting a equal to 0.50 and b equal to 0.5 in the equation of straight line, which is x equal to by, because x is the dependent variable, we get x equal to 0.5 plus 0.50 y. So which okay, it's the same, but I won't confuse you, because this is your a value here, this is your b value. So a value 0.50 and your b value was 0.5. okay, 0.5. so this is the regression equation of x on y. So which means if you have a line, for example, if you're trying to fit a line through a scatter, and if you draw a line, let's say it looks something like this, this line will represent the equation x equal to 0.50 plus 0.5 y. So that is the idea of applying the least squares method for fitting or finding a regression line, or the regression equation of the dependent variable on the independent variable. So here you're finding the regression equation of x on y, where x is the dependent variable and y is the independent variable.